Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. Please give one like and subscribe my channel, students. Thank you, students. In today's session, I'm going to discuss about the oxidation number topic, students. This is the topic from Redox Reactions. Here, I will give the best trick, students. You can easily find the oxidation number of any element, students. Okay, na? In molecule you can easily calculate, students. This is the topic from 11th class known as first PUC. Clear, students? Right. Now first one, trick number 1, students. What is the trick number 1? Trick number 1. So here in trick number 1, students, what I am taking, same elements I am taking, students. For example, x, two elements are same. Okay, na? So in between the same elements, students, if suppose single bond is there, single bond. Okay, nama? So if you break this bond, students, if you break this bond, okay, break this bond, no contribution, students, between the two atoms. Okay, nama? If you break this bond in between the two atoms, there is no sharing of electrons, there is no contribution. So that's why oxidation state of these two elements, students, 0 0. Clear this one? Oxidation number is 0, students. Clear? Same elements, between the same elements, if you break this bond, students, single bond is present. If suppose single bond is present, then if you break this bond, they will get the oxidation state 0, students. Are you clear? Oxidation state is 0. Now if suppose in between the two same elements, students, double bond is present. If double bond is present, now in between the two elements, same elements, that means they have the same electronegativity, students. Based on the electronegativity value I am saying, okay now. So the two elements are having the same electronegativity, so that's why their oxidation state is 0, students. Are you clear? So if you break this bond, students, if you break the double bond, their contribution is 0, students. There is no contribution, so that's why their oxidation numbers are 0. Are you clear? Oxidation number 0. Next, same elements only I am taking. If triple bond is present between the same elements, that means they have the same electronegativities. Are you clear? Same electronegativity values they have. Okay, same electronegativity values. So when if suppose you break this bond, then what will happen, students? These two elements will get the oxidation number 0. Are you clear? Oxidation number is 0 because they have the same electronegativity values, students. So that's why here oxidation number is 0. Okay, 0. Now I am taking the different electronegativity elements, students. One is, now here I am taking different electronegativities, different electronegativity values. So here I am taking one X element, another one is Y element. Okay, now in two elements, if suppose one element is having the more electronegativity value than the other element. So for example, I am taking Nana here, that Y is the element, it is having the more electronegativity than X. Okay, na? So Y is having the more electronegativity. I am taking here like this. Y is having the more electronegativity. Y electronegativity value is greater than X electronegativity. Clear this one? X electronegativity. Clear? So Y element electronegativity is greater than X element electronegativity, students. So here, if suppose in between the two different elements, students, here suppose bond is there, single bond is there. So if you break this bond, students, what will happen, Nana? Here Y is having the more electronegativity than X. Correct? Y is having more electronegativity than X. So that's why here what will happen, students? This is more electronegative element. So that's why it attracts the shared electron pair towards its own direction. So that's why this bond moves towards Y side. Are you understanding? Towards Y side. So that's why bond means 2 electrons. So that means it is attracting 2 electrons. So that's why its oxidation, it is gaining 2 electrons. So that's why its oxidation number is minus, its oxidation number is minus 2. And here this X element, it is now tell me students, here X element, here X is that means only one bond moving towards the moving towards y towards which side students, electronegative element y side. So that means here this bond is moving towards y side, so that's it. Just sorry students, take here -1. Okay, okay, so it is gaining one bond, so that means this bond is moving towards y side, so that's why its oxidation number is -1, and this X lost that bond, so that's why here +1 oxidation number. Are you clear students? +1. Understood, Amma? So this is about A single bond, X single bond, Y. Different elements I am taking. Okay, now if suppose double bond is present, if suppose double bond, A double bond, X double bond, Y. Okay, X double bond Y. So here Y is more electronegative than X. That means here two bonds are there. If suppose two bonds are moving to Y is more electronegative than X, that means here two bonds are moving towards Y side because it is more electronegative element. That's why it attracts a shared pair of electrons towards its own direction. So that's why here it is yeah, two bonds are moving towards Y side. That means here -2. Here oxidation number, it is gaining minus, it is gaining two bonds, it is losing two bonds, so that's why +2. Okay, now plus indicates lost, minus indicates gain. Clear? Next, now I am taking triple bond. If suppose triple bond is present in between X and Y, triple bond is present. Now what happens students? Y is more electronegative than X. Y is more electronegative than X electronegativity. So that's why it is more electronegative element. It attracts the three bonds towards its own direction. So that's why its charge is -3 students. This charge is +3. Clear? It is gaining three bonds. It is losing three bonds. That means these three bonds moving towards Y side, that's why -3. It is gaining minus, it is lost, understanding X lost, so that's why you have to take +3. Are you clear students? So different electronegativity elements there means like this, same electronegativity is there means the two elements will get the oxidation number 0. If different elements are there, that means one element is having the more electronegativity and another element is having the less electronegativity, then their oxidation numbers like this. Are you clear? So oxidation numbers, these are all oxidation numbers students. Are you clear? Madam, you will get in exam point of view students, you will get the doubt. Madam, here you are saying Y is more electronegative, X is less electronegative. Here in the place of X and Y they will give the elements, but how to identify which element is having the more electronegativity? Is it correct? Yes, you will get the you will get some doubt. Yes, now I will give the some elements electronegativity values students, then that values just you remember, you can easily answer such type of bits. Nana, now see students, trick number 2. Trick number 2, now I am taking the elements Nana. Hydrogen, from here hydrogen I am taking students, hydrogen, next helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Up to fluorine I am taking students. Okay, Nama? Understanding students? See students, hydrogen, helium, lithium, beryllium, boron, okay, carbon, nitrogen, oxygen, fluorine. Okay, till fluorine I am taking Nana. See here hydrogen oxidation numbers discussing students. Hydrogen atomic number is hydrogen electronegativity values. I am discussing the electronegativity values students. Electronegativity values. Okay, electronegativity values amma. Hydrogen how much Nana? Hydrogen is 2.1. Hydrogen oxidation number electronegativity value is 2.1. Helium electronegativity value is 0 students, because it is a noble gas element, already it is stable, so it is not ready to gain electrons. If it gains electrons, it loses its stability. Are you clear? So that's it is not having the tendency ready to accept the electrons. Already it is stable. So that's why oxidation number is 0. Sorry, electronegativity value is 0, students. So from lithium, students, here electronegativity values, lithium is 1, students, 1.0. Clear? 1.0. Lithium. Beryllium 1.5. This is 2.0. 2.5. This is 3.0. 3.5. This is 4.0. That means just you have to add zero point 0.5, zero point 0.5, nana, 1.5, 1.5 plus zero point 0.5, 2.0, 2 plus zero point 0.5. That means here just you add zero point 0.5 difference. Understanding, students? Just difference how much, nana? 0.5. Just add 0.5, zero point 0.5, you will get these all values. Okay na? So from lithium, this is which period element, students? Second period elements kada. These are all second period elements. Okay. And next third period elements also I am taking, students. Third period elements, which one, students? Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Okay, up to chlorine I am taking second period elements. Now tell me, students, what are the electronegativity values? Sodium electronegativity value 0.9, amma. Okay now, so after 0.9 up to here phosphorus, students, up to phosphorus just add 0.3. How much you have to add? 0.3. 0.3, 0.9 plus 0.3, how much, students? 1.2. Add 0.3, then 1.5. Add 0.3, 1.8. Are you clear? Just add 0.3, 0.3, nana, 1.8. Again add 0.3. How much you will get, students? 0.3 means you will get the value 2.1. 2.1 you will get. 2.1. And coming to the sulfur, students, here 0.4 add, 0.4 means 2.5. Clear? Next add 0.5, then you will get value 3.0. Just nothing, students. Here see, here what you which value we added from here? 0.5. Are you clear? Just you have to add 0.5 here. Okay, 0.5, 1 plus 0.5, 1.5 plus 0.5, 2 plus 0.5, 2.5, like this. Just add 0.5, 0.5. But in the case of second period elements, from sodium to sodium value 0.9, you have to remember. From here to till phosphorus, which value we added, nana? 0.3. Just add 0.3. Clear? 0.3 you have to add up to which one, students? Up to phosphorus. Clear? Up to phosphorus add 0.3. Sulfur, which one we have to add? Sulfur 0.4 add. Chlorine, how much, nana? 0.5 add. Clear? 0.3, 0.4, 0.5. Understanding? See, like this and matter. Okay, that means which element is more electronegative, you can easily answer this type of bit, students. Okay, now just you remember these electronegativity values. Hydrogen 2.1, helium 0. It is helium is noble gas element, electronegativity value 0. Lithium, this is first period elements, this is second period elements, sorry, second period. These are the third period elements. Are you clear? Third period elements, right? Now I will discuss examples, students. Some examples how to find the oxidation number by using these tricks. Okay, now by using these tricks, same electronegativity, different electronegativity, and based on these elements also. Okay, now we are going to discuss the examples, students. I will take examples. First example, example 1. First example, students, C3O2. Before that, one example I will discuss, H2. Okay, H2 molecule I am going to discuss. H2. I have to find the hydrogen oxidation number. Here same atoms are there. 2 hydrogen atoms, same atoms are there. Okay, now based on the structure. This is the structure of hydrogen H2 molecule. Now, in both are same atoms, now H2, same elements are there. So that's why here whenever bond breaks, students, their oxidation state, that means they won't get any oxidation numbers. Are you clear? Because they have the same electronegativity values. Whenever bond breaks, they will get the oxidation number 0, 0 over. Are you clear? So oxidation number of hydrogen, how much, students? 0, and here also 0. Clear? Same electronegativity. Here trick number 1 I told, na same electronegativity value, same elements there, means oxidation number 0. Okay, right. Now I am taking the second example, students. Example 2. Example 2 nana, HCN. HCN. So in HCN, students, what is the structure? First, based on the structure, I will discuss the oxidation numbers. Now, what is the structure? HC triple bond N. This is the structure of HCN. In HCN, students, here hydrogen carbon. In these two elements, which is more electronegative? Hydrogen, already I told you, hydrogen atomic number is 2.1. Carbon atomic electronegativity value is 2.5. Nitrogen electronegativity value is 3.0. Okay, so what are the elements are there that I wrote already? Here I discussed hydrogen 2.1, carbon is 2.5, nitrogen 3.0. Okay, now see this structure, students, how to find the oxidation number. Hydrogen carbon. Now hydrogen and carbon, but first you have to take these two elements, students. This bond I am taking, nana, in between two atoms, which is more electronegative, students? Hydrogen and carbon. More electronegative element is carbon, kada? So carbon is more electronegative, so that's why this bond is moving towards the carbon side. That's why it will get the -1 charge. Are you understanding? It is gaining one bond. Okay, and hydrogen, it is losing one bond, +1 oxidation number. And coming to nitrogen, this bond, these three bonds, triple bond is present in between carbon and nitrogen. So you have to see both elements, carbon and nitrogen, which is more electronegative? Nitrogen is more electronegative. That's why these three bonds moves towards nitrogen side, -3, and it is losing 3 bonds, so that's why +3. Are you clear? +3. Understanding, students? So that means here carbon oxidation number, how much, students? Here -1 +3, carbon oxidation number. So what is the carbon oxidation number, students? Oxidation number -1 +3. How much, students? +2. Clear? So carbon oxidation number is how much, nana? +2. Clear? Carbon oxidation number +2. So here it is showing the two oxidation numbers, -1 +3. Average, you have, not average, just you have to take -1 +3. How much, nana? -1 +3, 2. Okay, only one atom is there na, so you have to take -1 +3 +2 oxidation number. Carbon is showing +2. Right. Now third example, students. Example 3, H2O. Now tell me H2O structure. Coming to H2O structure, students, oxygen, hydrogen, hydrogen. Now oxygen is more electronegative. First I am taking these two elements. This bond I am taking. Oxygen is more electronegative. So that's why this bond is moving towards this side, this own direction. So that's why it will get the -1. Hydrogen will get +1 charge. It is losing one bond. And in between the two elements, here single bond is there. Here oxygen is more electronegative. So that's why here this bond is moving towards this own direction, oxygen side. So -1. Hydrogen will lose one bond. So +1. Now oxygen oxidation number, tell me, students. Oxygen oxidation number is -2, and hydrogen oxidation -1, total -2. Hydrogen +1. Are you clear? So hydrogen, so common oxidation number is +1. Are you clear? Hydrogen oxidation number is +1. Clear, students? So this is the H2O. Understood, amma? So oxygen oxidation number -2, hydrogen oxidation number is +1. Right. Now see, here also +1, here also +1 kada. Hydrogen same oxidation number showing, so +1 oxidation number. Now I am taking the fourth example, students. See here, fourth example, C3O2. C3O2. This is carbon suboxide. What is the name of the compound? Carbon suboxide. Carbon suboxide. Important students in competitive exams. C3O2. So what is the coming to the structure, students? C3O2. This is the structure. C3, 3 carbons, double bond O, double bond O. C3O2. This is the structure of C3O2, carbon suboxide. Now I want to calculate. Here students, I want to find the carbon oxidation number. Oxidation number of carbon, you have to find it. Carbon oxidation number. Here how many carbon atoms are there in this molecule? 3 carbons are there. That means here more than 1 atoms are present in the molecule. Then we have to find the average oxidation number, students. We have to get the oxidation number, what value we are getting, that is the average oxidation number of that element. Clear? Average oxidation number. Here 3 carbons are there. Okay, individual oxidation numbers, what they are exhibiting, and what is the average oxidation number of carbon, both I will discuss you. See here, first I am taking, see here, this carbon, this carbon, this carbon, 3 elements kada. First I am taking this 2, same kada, same atom. So that's why whenever bond breaks, what will happen? They won't get any charge, 0 0. And here also same carbon, same electronegativity values. So that's why whenever this bond breaks, these 2 carbons will get the oxidation number 0. Right, now this bond I am taking between carbon and oxygen. Oxygen is more electronegative than carbon, correct? So here already I told you, carbon and oxygen, which is more electronegative, 3 oxygen, and carbon is having less electronegativity. So that's what will happen, students. Here oxygen is more electronegative, that's why these 2 bonds are moving towards oxygen side. That's why its oxidation number -2. Carbon will lose 2 bonds +2. And coming to this bond, here oxygen is more electronegative, so that's why oxygen will get the oxidation number -2. Carbon will lose 2 bonds, that's why oxidation number +2. Now I have to find the average oxidation number. I have to find the average. Okay, average oxidation number of carbon. So these are the individual oxidation numbers. Here 3 carbons, in 3 carbons 1 carbon +2, another carbon 0, one more carbon +2. That means different oxidation numbers are exhibiting. I want to find the average oxidation number of carbon. So total 3 carbons are there. Okay, now total 3 carbons. Oxidation numbers, tell me, students. +2, this one carbon 0, this carbon +2. Clear? So total how many carbons are there? 3 carbons are there. So 2 + 2, 4/3 is the oxidation number. Average oxidation number of carbon, this one, 4/3. Clear? So this is the average oxidation number of carbon. It is equal to 4/3. So this is the, see students, next example. Clear? So this is the 4/3 plus 4/3 is the average oxidation number of carbon atom. These 3, my +2 and 0, these are the individual oxidation numbers, nana. Okay na? 3 carbons, each carbon atom, 3 carbon atoms are showing 3 different oxidation numbers. Understanding? Okay nama, 3 oxidation numbers. Through the structure, this is the oxidation number of, average oxidation number of carbon atom. And through the formula also you can calculate the oxidation number of C3O2, students, carbon suboxide. Okay now, through the formula means 3 carbons are there, so I am calculating 3 carbons oxidation number. Carbon carbon oxidation number I want, and 2 oxygens are there. 2 into oxygen oxidation number is always maximum -2, so equal to 0. 3 carbons plus 2 into 2, total -4, so 3C -4, 3 carbons is equal to 4, carbon is equal to +4/3. So here whatever the value we are getting through the formula, that value is equal to the average oxidation number of carbon, students. Are you clear? Both are same only. Are you clear? Average oxidation number, 3 carbons, so that's why 3 carbons showing different oxidation numbers. Suppose if I want to calculate average oxidation number, that is 4/3. Clear? Average oxidation number is different, individual atoms showing different oxidation numbers. Clear? Right, now take one more example, students. Br3O8. Br3O8. So what is the Br3O8 students? Tribromo octa oxide. Tribromo octa oxide. Clear? This is the name of the Br3O8. Now coming to this formula students, Br3O8, here structure Br3O8. Coming to the structure, here place is not sufficient. I am taking one more page. See Nana, Br3O8. Tribromo octoxide. Now coming to the structure students, three bromines are there. 1, 2, 3. Three bromines are there. Double bond O, 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 double bond. This is the structure of tribromo octoxide Br3O8. Okay, now here how many bromines are there? You have to find the oxidation number of bromine here. Oxidation number of bromine you have to find. Okay, now so here whatever the oxidation number you are finding bromine, that is the average oxidation number of bromine students. Are you clear? Now I am calculating the individual atoms, three bromine atoms separately. We are calculating the oxidation number. Now see, first I am going to calculate same elements. Between the same elements, single bond is there. This bond, whenever this bond breaks, this bromine will get 0. This bromine also will get oxidation number 0. And between the same two elements, same elements, whenever bond breaks, it will get 0. It will get 0 oxidation number. Okay, now I'm going to calculate here. Okay, now between oxygen and bromine, oxygen and bromine, oxygen and bromine. Okay, now see students, in the here oxygen bromine, which is more electronegative, oxygen is more electronegative. So that's why here these two bonds move away from the bromine. These two bonds move away from the bromine. These two bonds move away from the bromine towards oxygen. Yes or not? Total 6 bonds moving away from bromine. 1, 2, 3, 4, 5, 6. Move away from the bromine. That means 6 bonds are moving towards the oxygen side. That means oxygen side, bromine, how many bonds are moving away from this bromine students? 1, 2, 3, 4, 5, 6. That means plus 6 it is showing. Are you clear? That means it is losing 6 bonds. And this oxygen side, how many bonds are coming? 2 bonds are coming. Okay, Nama? 2 bonds. That means here minus 2. This also minus 2. 2 bonds. This also minus 2. Now coming to this, bromine completed 0. This is also 0. Now coming to here, oxygen, bromine, oxygen, bromine. Here also oxygen is more electronegative than bromine. So that's why here 2 bonds, here 2, here 2. Total 6 bonds are moving away from the bromine towards oxygen side. So that's why here also bromine oxidation number is plus 6. Are you clear? Plus 6. Understanding? So here plus 6, this oxygen minus 2, this is minus 2, this one is minus 2. Okay, now coming to here, oxygen and bromine, more electronegative element is oxygen. That's why these two bonds move towards the oxygen side. So minus 2, this bromine will get plus 2. Are you clear? It is losing 2 bonds. And in here bromine and oxygen is more electronegative. So it is showing minus 2. And here bromine lost 2 bonds. So that's why plus 2. Are you clear? So total here this bromine element, total 3 bromine atoms are there in this formula. So here 1 bromine plus 6, second bromine here plus 2, here plus 2, here 0. Are you clear? Plus 2, 0, plus 2, plus 2, 0, plus 2. Total how much students? Plus 4 here showing. Are you clear? This bromine is showing how much oxidation number? Plus 4. Are you clear? Plus 4 showing. Understanding, Nana? Plus 2, 0, plus 2. And this bromine plus 6 plus 0. That means plus 6 only showing. So different oxidation numbers are showing, students. Okay, Nama? Now we have to find the average oxidation number of bromine. Average oxidation number. Average oxidation number of bromine. Now tell me, students, 6 here, this bromine is showing plus 6, plus 4 and plus 6, 3 bromines. Take that values, plus 6, plus 4, okay, plus 4 and plus 6, plus 6, plus 4, plus 6. Total how many bromine atoms? 3 bromine atoms are there. Are you clear? Total 3 bromine atoms are there. Understood, Amma? Total 3 bromine atoms are there. So that's say by 3. Total how much, Nana? 16 by 3. This is the average oxidation number of bromine. Clear? Average oxidation number of bromine. Okay, so here 3 bromine atoms are showing 3 different values, plus 6, plus 4, plus 6. Average oxidation number means plus 16 by 3 you will get. So this is the Br3O8 formula. Now I am going to calculate the last example, students. Last example, Na2S4O6. Na2S4O6. Now coming to Na2S4O6, students, when it is dissociates, Na2S4O6, okay, now when it is dissociates, Na2S4O6 dissociates into 2Na plus S4O6 minus 2. It dissociates into 2 ions, Nana. It dissociates into 2 ions, 2Na plus S4O6 minus 2, right? Now coming to the structure Na2S4O6. Now see, students, in Na2S4O6, Nana, which type of bonds, which type of bonding is present, Nana? Covalent bond or ionic bond, which type of bonds are present? How many types of bonds are present in this compound? See here one is cation, another one is anion there. So that's why between the positive and negative charges ionic bond is formed. And one more is between sulfur and oxygen, students, in this compound ion, sulfur and oxygen single bond, that means covalent bond is existing. That means this molecule is showing the two different types of bonds. One is ionic bond. Ionic bond is possible because between the metal and non-metal, because sodium is it is highly electropositive element, first year group elements, alkali metal. So that's why between metals and non-metals ionic bond is formed, and between the non-metal and non-metal covalent bond is formed. Are you clear? So that's why here two types of bonds are existing, ionic and covalent bond. Clear? Right. Now coming to the structure, students, S4O6 O6 2 minus. This structure I am taking, Nana, S4O6 S4O6 minus 2, O6 minus 2. Take first S 4 sulfur, take S4 O6. See here double bond O, double bond O, double bond O, double bond O. Total how many oxygen, students? 6 oxygens kada. 1 2 3 4. One more oxygen here, minus. One more oxygen, minus. Minus 2 kada, right? This is the structure of S4O6 minus 2. This is the structure of S4O6 minus 2. Right. Now we have to find the average oxidation number of sulfur. Oxidation number of sulfur you have to find it. Are you clear? Oxidation number of sulfur you have to find. Now tell me, students, here 4 sulfurs are there. Now here between the same elements, whenever bond breaks, this will get 0, this will get oxidation state 0. Between the same atoms, this bond will break 0. Between the same elements, whenever this bond breaks, this oxygen sulfur will get 0. Clear? Now see here, between oxygen and sulfur, just a simple trick, students. How many, here oxygen is more electronegative, how many bonds are moving away from the sulfur? 1 2 3 4 5. That means what is the oxidation number here? Plus 5 sulfur. And this one also 1 2 3 4 5. 5 bonds are moving away from this sulfur. So that's why here, because oxygen is more electronegative, it is attracting towards its own direction. So that's why here sulfur 1 2 3 4 5 bonds it is losing. So that's why here oxidation number is plus 5. That means average oxidation number means what you have to find? Average oxidation number of sulfur is equal to how much, Nana? Plus 5, 0, 0, and sulfur one more plus 5, showing total how many sulfurs are there? 1 2 3 4 4 sulfurs are there. That is the average. Total 10 by 4 plus 10 by 4, then how much you will get, students? 4 2 point 4 2s are 8 kada. 2 will get, 2 means 20, 4 5s are 20, plus 2.5 is the oxidation number of oxidation number of sulfur. Clear? Oxidation number of sulfur 2.5 is nothing but it is the average oxidation number of sulfur. Are you understanding, students? It is the average oxidation number, average value. Clear? Individual sulfur atoms oxidation numbers understood, students? How to find it? Okay. I hope you like this video, students. If you like this video, please like, share, comment and subscribe my channel, students. Thank you very much, students.